All right, we have been looking at different types of numbers and how to classify those, working on some Venn diagrams to sort those numbers out. We need sometimes to be able to communicate efficiently with people sets of numbers that might not be the whole set. So we are going to look at some ways of communicating or representing groups of numbers. These are 5 common ways that I have up here, and I've got a few examples that we're going to work through. Okay, so for this first one, if we were trying to communicate to people the number of people that are in a coffee shop where the maximum occupancy of the coffee shop is 12, we could represent that on a number line. So on the number line, this one's a little bit tedious here. There might not be anybody there. There might be 12 people in there. There could be possibly 6 people in there, or there could be 9, or we could get 3 people in there, or 1 or 2, and we're going to end up with a bunch of dots on a line. That should be a 4 and a 5. I should probably do those in a different color. I'll go back in there. So 7, 8, 10, and 11. So on a number line, we could say there might be 0 or 1 or 2 or 3 or 4 or 5. It could be 6 or 7 or 8 or 9 or 10 or 11, or we could be at the maximum occupancy of 12. So that is what it would look like as a number line. Not a very efficient way of doing things, but sometimes it makes sense. A roster notation, the idea of roster notation is that we're just going to list the possibilities. So it could be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Roster notation works pretty well for integers. Okay? And we have, even if the integers go on and on and on, we can kind of abbreviate the pattern a little bit. We could probably also get away with this by saying it's 0, 1, 2, so on and so on until you get to 11 and 12. That would work for a roster notation as well. Okay. Our set builder notation. On this one, we're going to look at, I'll write it down first and explain what we're talking about. Okay, so this is read this way. The set of all n such that n is trapped between 0 and 12, including 0 and 12, and n is an element of the integers, or it's coming from the integers, which means we can only use those whole numbers as we go through here. So this extra piece that we add on here tells us that we don't have like 1.5. There's never 1.5 people in the coffee shop. That doesn't make any sense. Okay. So that's what set builder notation would look like there. Our interval notation, we wanted the interval notation. It's actually not going to work here. This is used for real numbers, okay, which we abbreviated as a capital R with an extra line through it, and that's true for the inequalities too. This is for real numbers only that we use those inequalities. So that is my example for number of people in a coffee shop with a maximum occupancy of 12. Now, my plan here is to not necessarily continue on with this, but I can do this. Let me make an extra copy of these, and I'll drag this down and get myself my next example. It's feeling like it's going to take a little bit longer than what I thought it was, but that's all right. I'll start talking faster. get these other examples down here out of my way. All right, so my next example is for the legal keeper size of a sturgeon on the Columbia River. So what size sturgeon can you actually keep? And I looked this up. On a number line, we could represent it this way. Okay. And it turns out the shortest one that you can keep is 38 inches, and the biggest one you can keep is 54 inches. So all we need to do is label those points on there. We're going to put a filled in dot on 38 and a filled in dot on 54 and draw a line between them, and it says everything in between there. So the one that is 47.6837521 inches long is a keeper that is in there somewhere. Okay. Shrink that down a little bit. I write just a little bigger than what this needs. The roster notation really only works for integers. So this is for our integers only. I can't list all of those possible things, which is what the roster is about. The set builder notation for this one, I can say this is the set of all x such that x is trapped between 38 and 54, including 38 and 54. And I don't have to specify that this is a member of the real numbers. That's just assumed unless I say it's something else. Okay. My interval notation, now that we have a real number one, my interval notation, I use a square bracket because of the less than or equal to, and I say this starts at 38 and it goes to 54, and the 38 and the 54 are included, and that's what the square brackets say. The inequality notation is going to look a lot like our set builder notation. We're just going to grab that inequality out of there and say this is 38 less than or equal to x less than or equal to 54. I'm going to pause this for a second, set it up a little bit better for okay, got that set up a little bit better. Our third example, we're going to look at the length of sturgeon that are illegal to keep on the Columbia River. So I'm going to start with my number line again. There is 0. They can go down to being very small. It's probably just talking about an egg at that point. 38 is going to be an important number for us, and 54 again is an important number. So we're going to use open circles on this because you can't really have a fish that's 0 inches long. It can get pretty short, but not all the way to 0. And up to 38 inches, we know if it was 38, we could keep it, but this open circle says you get up real close to it, and we can get up real close to the 54. And so then we're going to draw our lines in here on the number line, and I'm going to make this arrow go off that direction and say anything bigger than 54. I don't know how big a sturgeon can get, the limit on the size of it, so we'll just have the arrow running off that direction. All right, roster notation, again, this is real numbers, so the roster notation will not work for this one. Our set builder notation now is going to look like the set of all x's such that my x's could be between 0 and 38. Notice no equal to signs on here because those are not solid dots. The equal to parts fill in the dots. Or means it could come from this piece on the left, or it could come from the piece on the right. And this one we describe as being x greater than 54 inches. Okay. Our interval notation, in this case, we start at a 0 with a parentheses, because the parentheses corresponds to the open circle, not like those square brackets that corresponded to the closed circles and the equal to's in the inequalities. So this is from 0 to 38. Together with, this is called a union symbol. It looks like a capital U without the little tail on there. and then it picks up again at 54 and goes on forever to the right, and so we use the infinity symbol off there, although we know for certain that the sturgeon can't be infinitely long, but without knowing where to cut that off, that is the safe way to do that. And then we can, for the inequalities, we just extract this part from the set builder notation again. X is between 0 and 38, or x's that are bigger than 54. All right, next example. The weight of a letter that can be mailed with a first-class stamp. Okay, I looked this up. You can weigh something that weighs up to 3.5 ounces. So if we were doing this on a number line, I'll try to move this up, that. If we draw our number line, the important numbers on here are going to be 0 and 3.5. That is in ounces. And obviously, we're not going to try to mail something that doesn't weigh anything at all. 3.5 ounce one can be mailed. And so we are an open circle on one side and a closed circle on the other side, because 0 can't happen, but 3.5 can. The roster notation again is out, and because this can cover all those weight possibilities in between there, there'd be no way to list them. Our set builder notation is going to be the set of all x, such that x now is trapped between 0 and 3.5. Let me write that correctly this time. 0 and 3.5, including the 3.5, but not including the 0. The interval notation, the less than here, indicates that I'm going to be using a curved parenthesis there with the 0, comma, up to the 3.5, but the solid dot and the equal to on those previous ones correspond to a square bracket on that. And once again, the inequality is just extracted from the set builder notation. And we can say that the answers are the numbers that are between 0 and 3.5. That should be a decimal point there. Okay. And we're going to do one final example here. This example is all of the $2 items found at the dollar store. Okay. So I'm assuming that at this point there are none, so our number line, we'll go ahead and mark where the 0 is, but we make no other marks on there because there aren't any $2 items at the dollar store. In the roster notation, since there's nothing there, we still have the curly braces that we use on the roster notation, but we leave them empty. We put nothing in between them. It's called the empty set. And that can be an answer. Sometimes there is no answer to a problem. The set builder notation would probably just use exactly that same notation there. Doesn't really make sense to build it in that. In our interval notation, another icon for the empty set is a 0 with a slash through it. Okay. And there isn't really a good inequality thing that goes along with this either, so just wanted to show what it looks like when there are no answers at all. Now, if you happen to have checked out a book, an Algebra 2 book, then you can also find all of this information on pages 6 through 9 in the Algebra 2 book. That's all I'm going to say about it for now.